Morning, everyone. Our student chapter representative are having connection issues at the time, and Sudi Galvan, the faculty advisor. I would like to, on behalf of Christian, who was the host for this conference, I would like to introduce our speaker today. His name is Amitabh Saxena. Mr. Saxena is a Lean and Six Sigma Master Black Belt, CPHQ PMP, Balance Scorecard, Artificial Intelligence and Robotic Process Automation Consultant with 30 years of quality-related experience in manufacturing, logistics, banking, petrochemicals, healthcare, services, finance, and IT domains. He's training in Six Sigma at AXA University in Paris, certified by ASQ, and has consulted and trained more than 100 organizations in India, UK, Europe, and Middle East. By education, he is a chemical engineer in an MBA in finance. As Master Black Belt, Amitabh has guided more than 1,500 improvement projects, trained more than 4,000 black belts and 8,000 green belts. He also trained more than 2,000 middle and senior management personnel in strategic management, leadership, artificial intelligence, robotic process automation, Lean, Balance Scorecard, ISO 9000, CMM, and statistical process control. He has spoken at global and national summits for ASQ, IQPC, Marcus Evans, Indian Statistical Institute, NASCOM, and chaired leading conferences on process excellence. Besides, Amitabh is a very well-known consultant, having won many awards and appeared on many TV business channels like ET Now, CNBC, CBusiness, IBM, etc. He has received the Global Achievers Award in the Quality Excellence for the Economic Development Forum, Manipal Award for Achiever in Process Excellence Consulting, CEO of Beck's Six Sigma Institute in India, award from Brands Academy. In the past, Amitabh has worked in senior posting in KPMG, Deutsche Bank, Merckx in Denmark, AXA in UK, and was also associated with Quality Mission Project of Indian Statistical Institute, Indorama in Thailand, Ltd, and Bharat Petroleum. Presently, he is with Anexas, consulting leading organization in India, Middle East, and Europe on Six Sigma and process excellence implementation. For us, it's a great pleasure having you, Mr. Saxena, with us as part of our iWeek speakers. All our participants are enthusiastic about learning as much as possible from you. We really want to welcome you, and please follow the instructions provided at the beginning of the connection. Please mute yourself and turn off your video during this training. Welcome once again, Mr. Saxena.
Thanks a lot, and welcome to the Yellow Belt training, which will certify you as a Yellow Belt. If you want, you can appear for an exam, which is on our website, www.anexas.net. And that is optional, just to test your skills. But just by attending the session, you are entitled to become a Yellow Belt. So you should be able to collect a certificate within few days after completing this program. Okay, so welcome to the Lean and Six Sigma world, Lean and Six Sigma Yellow Belt certification. And I have got more than 30 years of experience in the industry, and I'm a chemical engineer. So I can correlate with you. I have even written a book, the Anexas story, about my journey of the company which I founded in Denmark, in Copenhagen, 14 years ago. And this is available on Amazon. If you want, you can buy it. The Anexas story. It also says there is an entrepreneur in you, in everyone. And today, I will tell you what qualifies me to speak to so many people, and of course, become an independent consultant, which anyone like you can also become. I have already, I think, talked about myself. Let me share something about my organization. We have got before I share some journey of my organization in Lean and Six Sigma, let me talk about the agenda. So first 45 minutes, we'll be talking about what is Lean Six Sigma, and we'll also learn some basic tools and techniques, statistical tools and techniques. Some of you might have learned this in your engineering or in your as part of your graduation. And then we will talk about DMAC, define, measure, analyze, improve, and control. DMAIC, what does define, what does measure, what do you do in analyze, improve, and control. After that, we will learn about some projects. I will choose maybe one or maybe two projects from oil industry and in general engineering industry. Actually, I have got more than 1,000 projects to share, but yeah, we don't have time for that. So I will share some of the projects. But just to tell you that Lean and Six Sigma is applicable in each and every industry, be it services or manufacturing. So I will share some case studies from other companies also. Maybe in the beginning itself, like first 10-15 minutes, I will talk about some other companies, including oil company, of course, how they have implemented Six Sigma and what have been the success stories where we have implemented Lean and Six Sigma in those companies. So that will generate some interest in you, that you like to know these tools and techniques which have made such a huge difference in so many companies. Towards the end, so for 2 hours, I would like to tell you about the tools and techniques. And last half an hour, I would like to devote some time for question and answers. If you have some questions, I would like to answer them. So usually this is a 2.5 hours to 3 hour journey, but usually we finish by 2.5 hours, so you can plan your time according to that. So let us begin with a question. Or before that, let us, yeah. So let us begin with a question. What do you think? Like, you can answer in the chat if you want. What are the similarities you find in those statements? A manufacturing company improves production by 30%. A hospital reduces discharge time of patients from 3 hours to 15 minutes. Recruitment cycle time in an oil company, oil multinational, preferably I will show this project to you, reduces by 64%. Hotel improves customer experience. Bank reduces errors. Insurance claims reduced by 70%. Insurance claims time, processing time, reduced by 70%. So what do you think? What are the similarities here? So time, okay. Efficiency improvement, yes. Kendry, you're right. Efficiency improvement. Andres, you are also right. Yes. It saves money, very important. So saving money, every project, okay, optimization. Okay. Quality improvement, yes. Absolutely correct, yes. So all of you are correct, and Lean Six Sigma is about that. All the projects actually all are improvement projects. They have used Lean and Six Sigma and data analysis to achieve breakthrough improvements. So one of the difference between the other methodologies and Lean and Six Sigma is it is highly data oriented. You have to collect a lot of data, you have to do a lot of groundwork before you make conclusions, before you think of improving any process. So the groundwork which is involved in any Lean Six Sigma project is a little bit more than other approaches like Kaizen or PDCA. All approaches are excellent. Everything is perfect to improve your processes. But in Lean and Six Sigma, the root cause analysis involves lots and lots of data analysis. So a little bit of statistics is involved. Of course, nowadays the statistics has been outsourced to the software. So the softwares are available. I'm not sure if you're exposed to Minitab, but in Lean and Six Sigma, the companies which implement Lean and Six Sigma, most of the time you have Minitab, which is being used in the companies. Very popular statistical software. I'm not here to promote Minitab. You can use any any software, but as I said, like most of the companies use Minitab. So I will even share some of the analysis in Minitab, and I will also tell you the journey. Like if you want to get an additional certification of, apart from your graduation, if you want to improve your employability, some more skills, add-on skills, you want to go for a green belt certification, why not? So how you can go forward, that also maybe I will share. I will talk about who are green belts, who are black belts, who are master black belts. Okay, so I will talk about the theory after a while, but as I was telling you, let me complete the formality of introducing the organization. So coming to the introduction of the organization, we have presence worldwide. I should color South America as well now, because I have done now through online trainings. This is an old slide, 6 months old slide. I've not updated it, but now we have covered almost whole world thanks to the COVID-19 pandemic. So we have trained more than 150,000 people worldwide in Lean, Six Sigma, and other artificial intelligence, RP, etc. We have done lots of projects. Just to prove that we have done lots of projects, we have some programs like London program, Mumbai program, Bangalore program, Middle East, Switzerland, China, Denmark, UK, USA. I would like to come to your country as well. Once everything is fine, I would like to definitely come and maybe give a lecture in person. I would be happy to do that. Maybe next year. Won a lot of awards around the world in various countries, appeared in TV shows, spoken in various conferences. American Society of Quality, I've been speaking for the last 5 years, continuously for 5 years on various topics. One time I spoke on oil industry.
On 21st of May, 2019, I'm going to speak in American Society of Quality's World Conference in Fort Worth, Texas. I'm going to talk about how one of the fields in artificial intelligence, robotic process automation, or RPA, can be used to support process improvement initiatives along with Lean and Six Sigma. We will see how this combination leads to improved productivity, improved quality, and reduced costs. Using a case study from a bank, I will share a roadmap to leverage the capabilities of existing quality programs like Six Sigma with RPA to produce better results. So see you there on 21st of May in Fort Worth in Texas.
So I have integrated different industries. So I've got enough, videos. Maybe I'll share the relevant videos to you. So all of this is possible only by improving some processes in the industries. Now, what Lean and Six Sigma can do for all the organizations? Let us have a look at it. So it does everything what a CEO wants, what a company wants, what a shareholder of a company wants. Everyone in the organization wants to reduce the costs. You ask anyone. Errors, defects to be reduced. They want waste, and we are not talking about the product waste, we are talking about the process waste. I will talk about it also. What are the 7 or 8 wastes of process? Rework. Anything which is not done right the first time is a waste. So we can reduce the waste as well. Then cycle times. Cycle times, time taken to complete an activity, delivery time, procurement time. In EPC, oil and gas, EPC, engineering and procurement company, contracting companies, maximum time is spent in procurement. All projects are getting delayed. Most of the oil industry projects get delayed due to procurement. You can reduce the procurement time, and in the past we have reduced it drastically to 50%, 60%, 80%. Then improvement about quality, production efficiency, productivity, customer satisfaction, everything, capacity, profits, money. And most importantly, in today's world, there's the word, resilience. Resilience means ability to come back, ability to bounce back. Given the situation today, which company is going to come back sooner, bounce back sooner? So that is resilience. Everything is improved using Lean and Six Sigma. Now, how is it done? It is done by following project's approach. Project is different from process. What is a process? Process is a repetitive activity. Repetitive means continuously you go on doing same thing again and again, again and again. Studying is a process. Appearing for an exam is a process. Yeah, you're involved in that favorite process of yours. Recruitment is a process. Recruitment in a final year. In a petrochemical company, producing polyethylene terephthalate ships is a process. Or producing oil is a process. In a drilling company, oil drilling company, drilling the oil is a process. Rig move is a process. Anything which is repeating is a process. Okay, traveling to college every day in the morning is a process. Anything which you are repeating. And how do you improve the process? First, you identify, you ask the customer. See, process produces an output. Every process produces an output. And output is of interest to the customer. So what do? You ask the customer, Mr. Customer, how do you feel about my output? Customer says, oh, I'm not happy. I hate you. You know, that's what they say. And every customer hates you. And then you will ask, you won't ask why. You will convert whatever customer is telling, we call it as voice of customer. You convert that to a measure. And you say, okay, today I'm performing at this level, and I would like to improve to a higher level, whatever it is. And this difference you achieve by doing a project. So project is done in a process. Okay. So all these things, reduction, cost, defects, waste, rework, and improvement of quality, efficiency, customer satisfaction, profits, is done by taking up improvement projects in a process. Now, what is the definition of a project? Project has got a starting point and project has got an end point. It doesn't exist after some time. It's a one-time activity. So you do improvement projects. Now, who does this improvement projects? The people in the process. People of the process. There's no consultant who does it. The consultant, the external consultant like me, they just come and maybe train the employees in some tools and techniques, and then we designate these employees as green belts and black belts, and they're allocated the projects. And these projects are done by these green belts and black belts who are working in the organization. Okay, so this is how all these things are achieved. This is how we have achieved in many organizations. So I have got, maybe I'll show you some organizations. 10 years we have been doing this for a logistics company. Again, it's in Middle East, and it's a heavily oil dependent economy. And they're one of the very, the biggest logistics company there. A lot of projects have been completed. The reduction of aging of outstanding from 4 months to 2.5 months. Service level 60% to 95% improved. Utilization of vehicles improved from 65% to 80%. So everything, and it increases the revenue by $3 million. So everything results in money. That is what Lean Six Sigma is about. For a bank, this bank became the top #1 bank in Oman within 4 years. Of course, I cannot claim that Lean Six Sigma was responsible for that, but Lean Six Sigma contributed to that journey. So again, a lot of projects done. Alpha Time Group is a very large group. Even the group which owns the Burj Khalifa, the tallest building in the world, there also we have done trainings and consulted. Toyota, actually Lean started in Toyota, and we have done trainings in Toyota as well. GE was the company which propagated Six Sigma. Actually, Six Sigma started in Motorola, but GE was the company which took it to the world, and it virtually forced all their suppliers to become or to adopt Lean and Six Sigma. They also told their employees that if you are not a green belt, you will not be promoted. So everyone wanted to be a green belt, and they did improvement projects, and they got a lot of benefits. So how it is done? So it is done by choosing teams to do projects. Okay. It is done to the teams. So we form the teams. Like I'll just share. Okay, let me share one video. Why not? So here, if I look at it, like in the beginning, when we launched Lean Six Sigma training, we conduct first champions training for the senior management. Maybe one of the videos I'll show you, if it is available, I'll show you later. So we train the senior management for 1 day. Just give you, we give them the brief overview of what is Lean Six Sigma, what you should be expecting from Lean Six Sigma. Sometimes we play a game, a relevant game, which is related to their process. And they develop some confidence and faith on Lean Six Sigma tools during that 1 day game and presentation. And then they are ready to spend 3 to 6 months or they're ready to sponsor the employees. Means they are ready to lend the employees of their processes to improve the processes to complete the projects. So this is what this is how you implement Lean Six Sigma. So this is, I think, the first day of one of the training programs, and we are forming the teams, and we have already formed the teams, and they have got the team name and the team slogan, and they also have songs.
And your slogan, 1, 2, 3, green air, and your song.
So they are the Lean team.
Let's not be. Let's not. 1, 2, 3, 4. Let's not be. Let's go Lean. Let's go Lean. We are the champions. We are a team. Wow. Your slogan. Your slogan. 1, 2, 3. Together, everyone. And your song.
Okay, so that's how we do Lean Six Sigma projects. It's not boring. Okay, this is ADNOC company. It's the largest oil company of UAE, United Arab Emirates. So this is the one.
4 years ago, somewhere in Middle East, one of the largest oil companies took up a Lean and Six Sigma project to reduce the rig move time from 7 days to less than 3 days. By doing so, they would increase their production capability without investing in additional equipment. I'm Amitabh Saxena from Anexas Consulting, and on 2nd of May, in American Society of Quality's World Conference, I'm going to talk about how around 50 people of different nationalities came together to solve a problem which was considered to be very, very difficult. In our journey, we used lots of Lean and Six Sigma tools and techniques, including the change management methodologies and advanced statistical tools. In our 10 years of existence, our company has completed many projects, but this project still stands tall amongst all of them, just like Burj Khalifa. So see you there on 2nd of May in Charlotte in USA.
So this was another project which maybe I will share this project with you today because I understand many of you or almost everyone is from oil industry. Yeah, I hope my assumption is correct. So many ministers in government ministers have also attended. This is Oman Oil Company. So many engineers doing the projects. Okay. So how do you do this? By following Lean and Six Sigma approach. So we will talk about Lean tools and techniques, some of the Lean tools and techniques, and we'll also talk about some of the Six Sigma tools and techniques. We'll understand what is average, what is standard deviation, what is the application, in fact, more importantly, application. What is the process under control? What is the voice of process? What is the voice of customer? All these things we'll understand. And then we'll see how do we do the projects, what are the tools involved in doing the projects, and also see the demonstration of some application of statistical tools and techniques using Minitab. Okay, so let us begin with understanding what is Lean. So in short, before I go into the details of our tools, in short, Lean is about mapping the process. You map the process. We call it as a value stream mapping. You take a pen and paper in hand, or maybe pencil and paper in hand, and walk with the process. Here you do a Gemba investigation. Gemba means go to the field. In Japanese, Gemba means go where the action is. So go to the workplace, walk with the process. And once you walk with the process, you will find that a lot of things are taking place which are not adding any value. So what you have to do? You have to either eliminate or reduce those non-value added activities, or at least acknowledge those non-value added activities. Maybe today we are not able to reduce them drastically. Maybe we are accepting them. Like one of the processes we accept today, most of the organizations, approval process, approval. Just to take an example, like procurement. To procure some material in an organization, you have to have sometimes 4, 5, sometimes 10 approvals. And out of 10 approvals, 8 of them are adding no value. People are just signing it because it's part of the process. So if we are doing this, we identify such process steps and you eliminate them or at least reduce them. This is what is known as reduction of waste. There are 7 or 8 kinds of waste. They are overproduction, waiting, transportation, overprocessing. So overproduction means producing more than what is required. Because if you produce more than what is required, you will invest money and even time and a lot of resources in storing that finished product. It is of no use. It is not adding any value. And then waiting time. A process step which is waiting for the previous step to complete its job is a waste. Now, transportation. Lot of transportation in the industry is of no value. So you have to critically evaluate each and every transportation. Is it adding value or not? Many times you'll find that much of the transportation is not adding any value. Like for example, today, this pandemic has proven that a lot of the transportation was not adding any value. So without transportation also, companies are able to complete their tasks and jobs, sometimes in a better way, at a lesser cost. So if the transportation is not necessary, it is not adding any value. It is a waste. We call it waste. Over-processing means doing something more than what the customer expects. So that is also a waste. You are wasting your company's resources in doing something which is of no value to the customer. You think it is of value, but no, the customer doesn't feel like that. Inventory, there's a lot of inventory waste. Finished good inventory, work in progress inventory, and the raw material inventory. You will be surprised to know that many companies have eliminated the warehouses, saved millions and millions of dollars. And many car companies I'm talking about have almost eliminated the warehouses by implementing something called as just-in-time and just-in-time production, and reduce the inventory so much that they've saved so much money that they have set up 2 or 3 more production units. It was almost a zero cost because that money came from the money saved from the warehouses. So inventory is a very big waste in the organizations. If you target to have zero inventory, of course you have to work towards it. It's not that easy. So if you work towards a zero inventory, you'll find that a lot of money can be released for some better use. So inventory is of no use. Inventory is waste. Rework, rejections, waste. If you're producing a rejected product or defective products, of no use. And underutilized resources or intelligence of the organization, intelligence of the people, if it is not utilized, it's a waste. So there's so much of waste in the organization that even if you just work on this, it will save a lot of money and a lot of time for everyone. So this is one area. If you're focusing on that part, we say that you are implementing lean. I just summarized the whole lean in just a few minutes. Of course, it has got a lot of tools. It has got a methodology. And what we are learning today is if we can combine both lean and Six Sigma, the methodology of DMAC, define, measure, analyze, improve, and control. Most of the companies in the world, they follow DMAIC, define, measure, analyze, improve, and control. DMAC is a methodology used to improve the existing processes which are existing. If you are trying to design a process so that it doesn't produce any defects, we call it a design for Six Sigma. We follow DMADV. So we are not talking about DMADV. We are talking about DMAIC. So it is the most popular methodology because most of the times the companies are interested in improving the existing processes. So this is about brief about lean. And Six Sigma targets, of course, it's a project-based approach, which I already told you, and it targets to reduce the variation. So most of the time, variation is the enemy of the excellence. Too much of variation produces defects. So anything which is beyond the customer specification limit. So if you see here, customer has specified some limits. We call it as upper specification limit, USL, and LSL, lower specification limit. So upper specification limit and lower specification limit is what the customer wants. It wants the product within those limits. But customer may want anything. The process wants something else. Process doesn't listen to the customer. Process is a non-living thing, isn't it? Process is not a it cannot understand what the customer is telling. So process behaves in the way it wants based on how much training you have provided to your people, what types of policies you have, what processes you have given them, what equipment you are using, what type of automation or whatever the resources or the infrastructure you have. Combined together, it produces an output of a process. And this output is the voice of customer, voice of process. Process tells you, I will behave like this. Like, for example, this process. And most of the processes, they follow normal distribution. Most of the repetitive processes, they follow normal distribution. Mr. Gauss, he found this. And in the 19th century, he studied patterns in the world around him. And he discovered the normal distribution. And he said that everything has got an average and everything has got a standard deviation. So I'll talk about that a little bit more in a short while. So if you are trying to reduce the variation, what will happen? You'll produce fewer defects. So for example, if intrinsic viscosity of a petrochemical product, or let me take a simple example instead of talking about technical terms. Let's say you are manufacturing a pen, some item, any item. Let's say pen. Now, customer tells you that it should be within within 10 centimeter plus minus 1 centimeter. Let us say. Let's. So here it should be between 9 and 11. Now, if you are producing between 8, this is your process, producing between 8 and 12. So any pen which is lengthier, like longer, is more than 11 is a defect, and any pen less than 9 is a defect. So if I reduce the variation in my process, something like this, I'm not producing any errors. So the aim of Six Sigma is to reduce the variation, and it's not like the sole aim of Six Sigma is to reduce the variation. I'm just telling you if I were to describe Lean and Six Sigma in just 10 or 15 minutes, I would use this explanation. Of course, Six Sigma is a philosophy. Maybe we'll learn more about it as we proceed. It talks about sigma levels. You measure your how many defects you are producing, and based on how many defects you produce, any defect means that whatever dissatisfies the customer. So based on how many defects you are producing, you convert this into a sigma level. So higher the sigma level, lower are your defects. More the defects, lower is your sigma level. So at 3 sigma, you are at 93% quality, so around 7% defects. At let's say 4 sigma, you are at around 99.4% quality, so you are at 6,000. You are producing just 6,000 defects per million opportunities. And at 6 sigma, you are at 99.99996% quality, means you are producing just 3 defects in 1 million opportunities. So Lean and Six Sigma in total, together, they improve any process. So before I just go into the tools and techniques used in Lean and Six Sigma, let us see if as an organization, how do we implement Lean and Six Sigma? Partly, I have already told you, I shared some examples of other industries who have done this, but let us look at theoretical explanation of how do we implement Lean and Six Sigma. So first, we create an infrastructure. We have a team of master black belts, green belts, black belts. If they are trained before, like you have an option, as a student. By the way, after I finish your training, a batch of some petrochemical institute, petroleum and chemical engineering institutes from Houston. Last time I did a program there, and some of the students chose to go for a green belt. So I'm actually running a session immediately after the yellow belt. I will enter into a green belt session. So these green belts are people who are trained in these tools and techniques, who have practiced those tools and techniques, and they can even apply these. As a green belt and a black belt, you are able to improve any process in any industry. And a master black belt is a person who conducts the training. Like, for example, I'm a master black belt who conducts the training, who guides, who consults the green belt and black belts as they do the projects. So here, you have a group of BBs. BBs means black belts, GBs, green belts, MBBs, master black belts, in a company. And I'm talking about the ideal implementation. So they might have got trained somewhere outside. This whole group can be outsourced to as a consultant, also consulting firm also, or you can have an in-house group. You can call it a center of excellence, or process excellence, PEX team, or whatever name you have in your organization. Some fancy name also you can create. Now these groups of green belts, black belts will be doing the projects, and maybe they will choose 2-3 projects from marketing, 2-3 projects from operations, 2-3 projects from finance, projects from each of these locations or businesses or departments, and allocate them to green belts and black belts. The green belts and black belts, as I told you, are from the organizations. These are the people who are coming from the organizations. They are working in those processes. So one person can improve the, let's say, oil production. Another person can reduce the waste of oil. And one project is given to green belt, another project is given to a black belt. A group of 2-3 green belts can do one project, or headed by a black belt. So you can have different arrangements, depends on what is the scope of the projects. Typically, green belt projects have got smaller scope, black belt projects have got larger scope. Green belt projects is capable, it's not like it's a thumb rule, it's a ballpark figure if I were to tell you, that it's around $100,000 to $200,000 they're able to save green belt, and around $500,000 they are able to, black belts are able to save. But these are, it's not that it has to save money, more important is the customer satisfaction. So even if you're not able to convert this into monetary terms or tangible units, still if it is intangible benefit, why not? You are encouraged to do the project. So you choose the projects, and champions are the head of the department on whose process you are doing the projects. So you have champions, and the process owner also. Process owner means the manager of the process in whose process you are doing the project. So this is how infrastructure is created. And a steering committee of the top 3 to 4 people, the senior managers in the organization, that is created so that they would monitor the overall Six Sigma implementation in the organization. So this is how the infrastructure is created. And then green belts and black belts are trained. First, we choose the projects. Yeah. So using some criteria, which of course is beyond the scope of discussion of our yellow belt training. So we use some criteria: voice of process, voice of customer, voice of employees, voice of business, and we create a laundry list of projects, and then filter them out using some criteria, and then we choose the projects. And once we choose the projects, then we go to the we conduct the training program. Yeah, I have got one, that champions training, also one-day champions training we conduct. So here is an example where we conducted a champions training. This, I think, Novartis in Switzerland, if I remember correctly. And here they're playing a game, and then they are getting convinced that really Lean Six Sigma works. So first, they try to improve a process without the tools, and then they use the tools, and they are able to improve the processes. And so before and after, they see the difference, and then they have more trust in these tools and techniques. So this is how you typically convince the senior managers. And once that is done, we train the green belts. And once we are training the green belts, then they are doing the projects. And once they're doing projects, we are monitoring those projects using different governance structures. Maybe I will not go into the details of that. But in general, in the next 3 to 6 months, you complete those projects. And over the 3 years, typically, you are able to make a huge difference in organizations. First year, you get some information about your what is Lean Six Sigma. You get sensitization, get sensitized to the tools and techniques. After that, second year, and of course, you complete some projects in the first year itself. Then after that, in the second year, you do some very, very high impact projects, leading to some millions of dollars of savings. And after that, of course, you become independent. It means you train some master black belts within your own organization so that you are able to run this whole initiative yourself. So this is just one way of roadmap. It's not that you have to use this 3-year roadmap. You can have 4-year roadmap. You can have 10 years roadmap. You can have 1-year roadmap. But I'm just taking an example that this is how you create a roadmap. So, we understood that how we do the rollout. Now let us learn a little of some of the tools. Yeah. So first thing which we learn as if you were to attend a green belt or a black belt, of course now you are a yellow belt. This is the first step towards becoming a green and black belt. So do you agree that some there are data is of 2 types? Some can be measured and some cannot be measured. Do you agree with this? So Lean and Six Sigma is data-oriented methodology. Yes, so as Kendry says correctly, most data can be measured. In fact, as a green belt and a black belt, we believe everything can be measured. So you cannot improve if you cannot measure. The 2 rules. You cannot improve if you cannot measure. And the second rule is everything can be measured. Everything can be measured. Now how? So there are 2 types of data. Usually when we are dealing with organizations, there are 3 responses. Some say we don't collect the data. Why we should collect the data? No one does anything with the data, so I won't collect the data. Or sometimes I'm afraid of exposing my inefficiency, so I don't encourage data collection. They don't say that, but that's what they mean. Second is we have too much of data, but we don't do anything with it. So why should I collect data? Another is that data analysis is too complicated, and I'm not a mathematics guy. I'm not a statistic guy. I hate maths. I have left my maths in my graduation. After that, I don't like it. Or we have in this organization which too much of data, and we suffer from analysis paralysis. We keep on analyzing, keep on churning reports after reports, and I don't know what we do with that. So in general, people don't like when we talk about data. They run away from you. When we ask for data, they say, oh, auditor, run away from him. Inspectors, quality professionals, I don't like them. So that's what happens with the data. But in Lean and Six Sigma, you fall in love with the data. Well, first of all, you have to remember there are 2 types of data, continuous and attribute. So let me talk about that first. Because before we learn the tools, we need to know the different types of data. Because if I know the data types, I can easily find out what tool to use, because the usage of the tool depends on the type of data. So let us have a look at the different data types. So there are two types of data. Continuous, of course, there are various names, but let me use the name widely used in statistics. So, and attribute. Attribute. Here, continuous, of course, also known as quantitative data, also known as variable data, continuous data, and attribute data is also known as qualitative data, categorical data. Sometimes they say discrete data also, although discrete may fall into both categories, continuous and attribute. So continuous data is like age. Yeah. For example, my age, 51.9. Oh, yeah. 9, only 15 days to go to become 52. Okay. So years. Yeah. Not 15 days, I think. Around 20 days, yeah, approximately. So we have got other example, time taken to complete a job. Yeah, say 21 minutes, 21.5 minutes, 21.5 days, whatever. So you'll find that one of the characteristics is it can be represented on a number line. The continuous data can be represented on a number line, and it has got a unit always. And it has got decimal points, decimal possibility of a decimal, because it's on a continuous line. So it can be represented on a number line, so it can take any value, 51.936825. That is continuous data. And attribute data is most of the time we feel, oh, I cannot measure. It's difficult to measure. That's what we say. So this attribute data has got an attribute which we want to measure. And then it has a category. I have a category. Then I can measure it as a count, as a number, but it is discrete count. I cannot have decimals there. And you have a proportion here. So like, for example, gender is attribute, and male and female, and 30 males and 20 females, and 0.6 and 0.4. This is your attribute data. So I cannot have 30.1 males. Happiness. Happiness, difficult to measure, but yes, we can measure. See, anything can be measured, at least in binary terms, like presence or absence of that attribute. Presence or absence of that, like presence or happiness, but absence, or like happy, not happy. Or you can have 5 categories: very happy, happy, neutral, unhappy, and extremely unhappy, whatever. So I'm just making maybe 2: happy, no happy, not happy. Happy and happy. And then I checked with say 100 students, and 60 were happy and 40 were unhappy. Okay, so it is 0.6 and 0.4 again. Oh, why I'm coming out with the same proportion? Okay, so 60 and 40. So here, just to prove that everything can be measured, anything which you feel cannot be measured, just put it here as an attribute. And the easiest way of creating a category is presence or absence of that attribute. And then you count how many times it appears, and then you can make a judgment about your process. You can make a judgment about any process, about anything what the customer wants. So whatever customer wants, you convert first into metric, a measure. How will you convert? Either attribute measure or continuous measure. Create a measure. Then see what is the performance today? How are you performing today in that, in terms of that metric? And display that to the world. I am performing like this. Like, for example, time taken to complete an activity. If I were to do that, I will make a histogram. Time taken, on an average, I take, say, 30 minutes or 30 days, 30 hours. And, probability distribution suggests that, I'm likely to take up to maybe 45 and up to, say, 15. Although none of the data which I've collected goes up to 15 or 45, but the population, I'm trying to predict the probability distribution curve of the population. I'm not interested in my sample. Yeah, just collected 15, 30 samples. So usually you collect around 30 samples. For continuous data, it's a very optimum sample size, 30 to 50. And here you collect around 200 to 1,100. Now there's a logical reason for that. It's coming from central limit theorem, which we discuss in Greenbelt and Blackbird, so there's no time to discuss that here. But using some very simple mathematical calculation, very, very simple. In fact, we love deriving the formula in our classrooms. And if time permits, maybe we'll derive the formula for standard deviation today. But let's see. I think there's some good time. Yeah. So first, I will try to finish our yellow belt syllabus. Then we'll try to go. So if I'm just displaying the performance of my process, if I'm just displaying the performance of the process, I will say that I will make a histogram for continuous data, but I cannot create a histogram for attribute data. Here I will have to create either bar chart like male, female, male, female, okay, or a pie chart, yeah. Happy and happy, yeah. Or I can also create a Pareto chart, like if I've got different categories, like 5, 6 categories, and if I arrange them in a descending order, like city, different cities A, B, C, D, and number of students coming from city A, B, C. If I'm just plotting that, I can make a Pareto chart. So Pareto or a bar or a pie chart. We're learning all these things just to prove that it is very easy to analyze the data. 30, 40, 50, 100 samples, good enough to make a judgment about your whole company. Yeah, it doesn't matter. Population size may be 1,000, 10,000, 1 million, 2 million, doesn't matter. There's not much enough time, but if there were time, I would have collected the data of the heights of people attending this program, and I would have got the distribution of all the people in your region. Yeah, the probability distribution. You can do it yourself later on by applying the normal distribution curve and calculating the average and standard deviation. I will make some assumptions and I will talk about that. Okay. So we have got, this is descriptive statistics. Now let us look at if I am trying to draw inferences, okay. Because Lean Six Sigma is about finding the root causes, finding the root cause of my problems. How do I find the root cause of my problem? By doing root cause analysis, and that too data-based, data-oriented, not simple root cause analysis, not intuitive, not experience-based, not based on my feelings. My heart says that this is the root cause. No, sorry, you're not allowed to say that. Deming used to say that in God we trust, rest others bring data. In God we trust, rest others bring data. That's what Deming used to say. Deming was a quality guru. That means I'm not going to trust you unless you present the data. So here, now if you look at inferential statistics, so it depends on if I'm planning to make an inference or correlate two factors which are, let's say, both continuous data, like age and time. So let's say time taken to complete an activity. Is it related to age? So if I were to find that, I will do both continuous data, I will do scatter plot. So time and age, both are continuous data. I can do scatter plot. As the age increases, time taken to complete an activity increases. Or it can be reverse also, yeah. In either case, it is related. Here it is positively related, here it is negatively related. And you can also create a regression equation. I'm not going to go into the details of that right now, but this is how you analyze the continuous and continuous data. Or it can be something like this as well, not related at all. Yeah, no relation. It's not the root cause. No. Age is not the cause of taking long time. Here it is. Here it is. Age is related to time. More the age, lesser is the time take to do some activity. Yeah. So everything is data oriented. That's what we are trying to do. And if we are trying to correlate, let's say, two let's say I'm trying to correlate these two, happy and happiness and time taken to complete an activity. If the employee is happy or not happy, does happiness impact the time taken to complete an activity? So I can just see that here. I cannot use a scatter plot because I have got now categories: happy, unhappy, happy, yeah, unhappy, and time. Happy, okay, it takes less time, more time. We call it as a box plot. We use box plot. It's known as box plot. It's a tool we learn in our green belt training program sessions. It may be like this. That means it is related. Both are related. Happiness impacts. So if you want to reduce your cycle times, keep the employees happy. Yeah. Or if it is like this, happy, unhappy, and time, doesn't matter. Employees happy or unhappy, you still take long time. So happiness has nothing to do with your time. Look somewhere else. When you're doing a root cause analysis, you are trying to find out the root cause and eliminating each cause one by one. So that is what you do typically in your root cause analysis. So here we are using box plot. So we call it as box plot. Here we used scatter plot. Scatter plot. And you also do regression. Here you use box plot, or there is another tool called ANOVA, which I will not be discussing in this program. So for each type of analysis, you have got a very specific tool. Yeah, so you learn a lot of tools in your green belt and black belt. And of course, once you are a green belt and black belt, you have got the confidence to solve any quality problem in any industry. It's not that only oil industry or manufacturing or services or IT, any industry. So any industry, you can confidently improve the processes. Later on also, you can become an independent consultant also, so gain some experience. And why not? In fact, most of the projects which are done by our master black belts, our team has got around 25 master black belts. And most of them are youngsters, like they're in the late 20s or early 30s. Yeah, younger means, of course, they're older than you, but relatively younger. Yeah, younger, as compared to people like me. So here, it's so simple. It's very simple. And nowadays, you have got all the tools and techniques. Many times automation also we are using. I'm not going into the details of that. First, let's try to understand the theory, and then practical applications. There are so many of these tools and techniques. So we have learned some tools and techniques. Yeah, data types. One more tool we can learn before we see some of the projects and we see how the projects are done. Because if you learn the tool, it's very easy for you to understand those projects, which I'm going to show you. One more tool which maybe I can talk about is most of the processes I told you are normally distributed. Mr. Gauss, he found this. Carl Friedrich Gauss. He found that whatever data you collect from whatever sample you collect from any process, you can predict about the population. So if I collect the travel time of you going from your say home to college, if you're not staying nearby. So let's say you are taking 30 minutes. I collected sample 35 minutes, 25 minutes, 29 minutes, and 32 minutes. Your average is, let us say, 30 minutes and standard deviation. So every data has got standard deviation. So this is 5. Standard deviation is 5. So very easily you can calculate. I will show you in case you want. I will show right away. I will start Minitab and maybe we can take up an improvement project. We can think of improving the scores of university students, improve the performance of university students. We can take up that project. Okay, so so it is very easy to get the standard deviation. So I get 30 here. Then Mr. Gauss, he found an interesting phenomena. He used to study the patterns of the processes, and he found that the curve never touches the x-axis. It goes on and on, like it goes up to minus infinity to plus infinity. Yeah, but it appears to touch the x-axis at plus 3 sigma and minus 3 sigma. Okay. And 99%, approximately 99.6%, but anyway, 99.73%, to be very precise. But let us not be so precise. So approximately 99% of the population, I'm not talking about the sample, I'm talking about the population. See, this is the sample. I know the sample, what is minimum, what is maximum, but I'm trying to predict about all my travels during the whole year, during the next 2 years, 3 years, 4 years, 5 years, till the time I'm studying and till the time I stay in the same home and go to the same college. Then this is what my average time and standard deviation time, and I can predict about all my travels. So here I can say this is 30, then this will be 35, 1 sigma. This is 1 sigma, this is 2 sigma. This is minus 1 sigma, minus 2 sigma, minus 3 sigma. So this is 35, this is 40, this is 45. This is 25, this is 20, and this is 15. So I've got 15, 20, 25, and 30, 35, 40, 45. And I can say that minimum time I will take 15 minutes, and maximum time I will take 45 minutes. This is known as lower control limit, and this is known as upper control limit. LCL and UCL. Lower control limit and upper control limit. And we call this as voice of process. So if I just put it here, lower control limit and upper control limit, this is 15, upper control limit is 45. So this means the process will always behave between those limits continuously. This is the histogram, historical data, all data collected together behaves like this. But if it's a control, this is known as control chart on the time scale if I measure. So maximum you are around 30, but sometimes going up and down, fluctuating, random variation. We call it random variation. And we say if the process is behaving within those control limits, we say process is under control. We say process is under control, right? So here my process is under control. Suppose you find one day you took 60 minutes. Then we say process has gone out of control. And for an out of control point, you can even assign a reason. So if you were to make a cause and effect diagram, this is one tool called cause and effect diagram, also known as Ishikawa diagram, also known as Fishbone diagram. So your travel time, and here is your reasons for that, like traffic and so many things, route, the vehicle used, weather, your mood, your which lecture you are going to attend. That also determines your travel time. So you keep on writing down all the causes. We call them as X factors, and this is known as Y factor. So I'm trying to correlate X and Y factors. So if my process is behaving within the control limits like this, I say my process is, this variation is due to common causes. All the common causes are acting on my system and producing this variation. But if this is happening, the 60 minutes, I have got a special cause, maybe traffic. One cause is responsible for this particular out of control points. We call it special cause, assignable cause. I can assign a reason to that. So this is how I create my control chart. And this is how I make my inferences. Process under control, out of control. Now, one out of control point or any special cause can be easily taken care of by the manager or the operation person who's operating, operator, engineer. He can easily take care of it through his logic, intuition, experience. Like 60 minutes. Why you took 60 minutes? You can easily say, oh, today it was traffic. But if I try to ask you, why this variation, sometimes 30 minutes, 33 minutes, 27 minutes, 25 minutes, why this variation? You will say, it's due to common causes. In my cause and effect diagram, I refer to the cause and effect diagram, it is due to common causes. That's what you will tell. So now what's happening here? Are you happy with the common causes and under control process? Not necessarily. Suppose, Your customer tells you that I'm not happy with your process. This is the voice of your process. But the voice of customer is telling, let's say, this is time taken to complete an activity. Yeah, time taken to complete an activity in a company. 15 days to 45 days. Customer tells, sorry, you should complete this in 10 days. Or suppose it's a sales company, then they will say something else here. Complete this is $15 million and $45 million is what process today. My sales are today between $15 to $45 million. It should be at least minimum 50 million. So that's what customers tell me. Now, if this is the case, process is under control, but it is not making the customer happy, isn't it? So in this case, what I will do, I will change my control limits, right? So I will change my control limits, and if it is sales, I will like to increase, get my new control limits. Or if it's, let's say, time taken to complete an activity, yep. So changing the control limits is not easy. It will not happen by using just using logic, intuition, experience. Here you need DMAC. Define, measure, analyze, improve, and control. Lean Six Sigma project only, because you have to change the DNA of your process. This is the way your process has been behaving for the last few months or so many years, maybe sometimes. You're always behaving. This is in the DNA of your process, 15 to 45 days, 15 to 45 minutes, 15 to 45 million of sales. These are all embedded in your process. And to change the DNA of the process will require some effort. So 3 to 6 months usually you take. So that's what. Now we have understood the theory part. Now let us look at the applications. So I'll show you a project, and maybe one project or maybe two projects, and then I will show you Minitab analysis as well, how easy it is, just to prove that it is very easy. And then we'll have some question and answers. So that's what we'll be doing now. So give me 1 second. So this is a company which is into construction of oil refineries and oil fields. And I'll take a simple process, although I've got some very good projects they have done, designing the pipeline for petrochemical plants, etc. But let me take a simple process, which everyone understands, because I'm sure everyone doesn't have that exposure to the industry at this point of time. So here, they wanted to reduce the recruitment cycle time. So as I told you, all projects follow the DMAIC, define, measure, analyze, improve, control. So the define phase, you do SIPOC, supplier input process, supplier input process output customer. So you focus on the processes. Again, the great quality guru Deming used to say that 85% of the problems are in the process, not in the people. The reason our products are defective or not satisfying the customer, 85% of the times, the reason is process, not the people. So first thing a person, a green belt or a black belt does is create a process map, simple process map, high level process map, 50,000 feet view of the process. We call it SIPOC, SIPOC. So when we are creating the SIPOC, we generally start from right to left. So identify the customers. Here it is the departments in recruitment. So who are the customers? Departments. Operations department most of the time. Output is the recruited employee and process. They describe inputs of that whole process and suppliers. And then you ask the customer, you collect the voice of customer. Sir, how do you feel about my output, the recruitment? And the department say, oh, you take too long to recruit your chemical engineers. I need to measure it. So I measure it. One of the measures is turnaround time. So I take this to the project charter and I create a project charter in the define phase. Again, we are still in the define phase. In the define phase, we create a project charter. Problem statement, we write a problem statement which states what is the problem, where is the problem, since when is the problem, how it impacts. You don't write why is the problem. You don't assign a reason there. So here you write the problem and then you write a goal statement. So today problem statement is, it is taking more than 60 days to recruit an employee. And the goal statement is, I would like to have all recruitments done, or at least 10 to 15% or 90% of the recruitments done within 60 days. Then if I am able to save some money, why not? So write the money. That's what you do. And then of course, scope of the project, CTQs, customer CTQs, etc. High level project milestones, you just write them here, define, measure, analyze, improve, and control. Every project charter, in fact, we are Anexas, our company is the REP, Registered Education Provider of PMI, also Project Management Institute. So I conduct the project PMP trainings as well. So the first thing which we talk about in projects, in our project trainings, is that for every project, you need to create a project charter. So there I am talking about large projects like refineries or petrochemical plants or some very big projects, construction of a building, whatever. But here we are doing small improvement projects within the company on the existing processes. So, but the project charter looks almost similar. So here again, you create a milestones. So typically 3 to 6 months, you will like to complete this project. Now comes the measure phase. Here you collect the data. And if the data is continuous data, days taken, I can make a histogram. And I can also create a box plot like days taken and discipline. Are they related? Is my number of days of recruitment affected by the discipline or the department for which I'm recruiting? Yes, no, I can use a box plot to measure that. Also, I define a defect. And before that, of course, I just told, I'll maybe tell you that we form a team as well, So the team in the define phase, we formed that the HR director is the champion. Process owner is the recruitment manager, and the team who are doing the Greenbelt projects are the names of team members. And this is me, Amitabh Saxena. Oh, connect with me on LinkedIn. I'll be happy to connect with you. I keep posting a lot of Six Sigma tools and techniques, tips. Not only they will help you in your Six Sigma journey, but otherwise also day-to-day life, these tools and techniques which we are learning are all applicable in day-to-day life. Sometimes I'll post like about FMEA, failure mode effects analysis, like how to prevent the failures, either in life, of course, or in processes. I think 3 days ago, I posted that video. So I keep posting my videos. I have got that habit. I don't sit quiet, keep speaking. Again, keep recording. So please take advantage of that. Connect with me on LinkedIn. Also, you can like our Facebook page, Anexas Europe, where I bring in the industry, the experts. They talk about some improvements in the industry. Sometimes they present their projects. Sometimes our certified master black belts, they come and present the projects. And sometimes our some well-known process improvement specialists around the world, they speak about their experiences. Sometimes students speak about their experiences. So welcome. You can connect on the Anexas Europe LinkedIn page also. So either whatever you want. If you want to connect, welcome, most welcome. If you don't want, it's fine. Okay. So yeah, we were in measure phase. So now we define a defect. Defect from customer's perspective. So here the definition of a defect is any recruitment taking more than 60 days is a defect. So how many defects I have? 27 defects, and out of 47 samples. So that means 62% of the recruitments are taking more time. So we convert this into a sigma level. There's a method of calculating sigma level, which is beyond the scope of yellow belt, but it's very easy. It's not that difficult. Only thing is it takes time for explanation. So so here we find that is we are at around 1 sigma. Around 62% of the recruitments are taking more than 60 days. That means defective. That means 62% comes to around, corresponds to 620,000 defects per million opportunities, which corresponds to 1.14 sigma level. So this is my measure phase. Then comes the analyze phase. In the analyze phase, we analyze why we are performing the way we are performing. So here we come out with process mapping, value stream mapping, identify the non-value added activities, which step is adding value, which step is not adding value. Identify all these activities which are not adding any value. Apply ESCAP technique. ESCAP means E-S-C-A-P. E means eliminate, S means simplify, C means combine, A means automate, P means parallel. So can I eliminate the step? Can I automate that step? Can I combine that step? Can I make it simplified? Can I simplify that step? Or can I make it parallel? Like, can these two steps be done parallelly? So here you are trying to do some process value stream mapping and value analysis. You're trying to understand the value added and non-value added steps in your process. And then once you get the value added and non-value added steps, you try to eliminate the non-value added steps, or you try to automate, or as I said, parallel escape analysis you can apply. You'll be surprised to know that 2 or 3 hours of little bit of an analysis of the process will reveal a lot of waste, and you can immediately improve the process. Because the process is designed in the organizations which you are going to join very soon. They have been designed 5 years, 10 years, 20, 30 years ago. Many of the oil industries, the processes they follow were designed 50 years ago. They never took the time to change those processes. Now, a process designed around 30 years ago doesn't know you have an email. A process designed around 8 years ago doesn't know you have a WhatsApp. So it doesn't know that the world is now digital. So a lot of things we are doing unnecessarily. So why not remove them? So do a good process analysis. And of course, you do this with the help of the team. Then you have got your cause and effect diagram. Cause and effect diagram is also known as Fishbone Diagram, as I told you, or Ishikawa diagram. You invite the people to brainstorm on all the possible causes based on man, machine, material, method, measurement, or environment. And they come out with all the possible causes, post it on the wall. And of course, you can't work on these causes. So many causes are there. So you filter them out using control impact matrix or using Pareto analysis. Wilfredo Pareto was an Italian economist who found that 80% of the wealth in Italy was with 20% of the people. So we call it as 80-20 rule, Pareto principle. And you apply this to Pareto. Mr. Joseph Juran, the quality guru, he applied Pareto principle to quality, and he said 80% of your problem, what you're trying to solve is due to 20% of the causes. So you have to find those 20% of causes based on data. So you collect the data, different ways of collecting data. You have surveys, you have got actual data collection, get to the files, get to the process, measure the process, whichever way you follow, and make a Pareto analysis. Here they have used N/3 technique, they voted for it, and you can see that the topmost causes, they are arranged in descending order now. So topmost causes are upfront CV screening, negotiation process, etc. And of course, I'm not interested in those causes right now. So let us look at the overall flow of the methodology of DMAC. So here I can create a Pareto very easily, just one click. Soon I'm going to show you how to create it in just one click. So here you create this Pareto analysis, and you can see that first 3 or 4 causes are responsible for 80% of the problem. So I use different rules of brainstorming where there are certain rules of brainstorming which you need to follow, like no idea is a bad idea, do not discuss the ideas, defer the evaluation, because if you start discussing the idea, people will stop giving you the ideas. No one wants to be criticized or evaluated. So in order to create some good number of ideas, you need to just jot down the ideas, don't discuss the ideas during the idea generation session. And then you, of course, focus on generating the quantity of ideas. Don't worry too much about the quality, because a pearl diver, he dives into the sea to get the pearls. If he just collects 10 oysters, he's not going to get the pearl. But if he collects maybe 1,000 oysters, the likelihood of getting the pearl is very high. Similarly, if you're looking for that great idea, collecting 5-6 ideas is not going to be sufficient. You have to collect more than 40, 50, maybe 100 ideas. So there are various techniques to generate those ideas, which we learn in Green Belt or Black Belt curriculum. And one of the tools they have used is 635 here. 6 people write 3 ideas in 5 minutes. Everyone writes idea on a piece of paper in 5 minutes. All the 6 people, everyone writes at one time. So you have 6 papers now with 3 ideas written on them. Now you exchange the papers. And then the other person looks at the idea written by another person, and this keeps on happening. Keep exchanging the papers. So in 30 minutes, you'll get 108 ideas. Okay. So you have got a lot of techniques like that. You apply those techniques, and once you apply those techniques, then you will get a lot of ideas. Then you choose the ideas to be implemented one by one, and that's what they did. And they were able to reduce the recruitment cycle time. Once you have reduced the recruitment cycle time, you would like to sustain the gains. You would not like to go back to original state. So you have some tools for that, like control charts, control plan, 5S, Pokayoke, all these techniques you can use. This we learn in our Green Belt and Black Belt programs. So typically, you would improve a process, you would like to sustain the gains. You like to make that improvement as part of the DNA of the process. So that's what they did. They reduced the recruitment cycle time, and they were able to sustain the gain for a long, long time. So this is how typically a project is completed. Let me show you one more project, and then I will show you some. Okay, first let me show you, instead of showing the project, maybe I'll show the project towards the end. Let me show you the analysis, the Minitab analysis. And I will take up a project like, so most of you are studying, yeah. So if my project was to improve the scores of the students, and I'm just taking some simple examples. So it's all made up examples. So don't think that this is representing any university or college. So scores of students in an university. Yeah. I collected some samples out of 100, let's say. The maximum score is 100. So one student got 60, 55, 63, etc. And then if it is continuous data, if you remember continuous data, I told you about some rules. You've forgotten. Let me recollect the rules. So continuous data, you will make a histogram. Attribute data, you will make a Pareto chart. If you are trying to do inferential statistics, then you will do box plot. And in case of continuous and attribute, and continuous and continuous, you will do a scatter plots. And then both are attribute, then you will do a Pareto chart. So let us see. I will show you the our example. So scores of students. So let me comment about this university now. I collected around 15 students. I will make a histogram because it's a continuous data. So on an average, we are scoring 61.7, 62%, and the standard deviation is 8.6. So I can predict, like if I take like round of the values here, so 60 and 10, let us say. So average is 60 and standard deviation is 10. So you have likelihood of getting a person who's scoring 90 marks, and likelihood of getting students who's scoring 30 marks. So 30 to 60, 90 is the process variation. My control limits, if you want to use the term. So lower control limit of my university student is 30, and upper control limit is 90. 60 plus minus 3 times the standard deviation. And process is under control. You can even draw the chart, control charts if you want. So although the process is under control, but I'm not happy with the process. I want to increase the average score. So today it is 60. I would like to, so today it is like 60 approximately. I would like to increase it. Yeah. I just made my assumptions of a 60 and 10, but actual standard deviation is something else. So based on that, Minitab has given me the values that it is likely to get a student scoring up to 85 and scoring up to 37 on an average 61%. So this is known as one type of control chart called Imr chart. In the green belt, you learn different types of charts like Imr, X bar R, U chart, C chart, P chart, NP chart. Depending on the type of data you are talking about, you will be getting the information, or you'll be using the chart. So now we have got this score. My aim is to improve the average scores, overall performance of the people in the university. So I use a cause and effect diagram, man, machine, material method, why low scores. So it's faculty, the student, focus, health, interest, books, laptops, desks, classrooms, all these, whatever you can think of has been listed here, and you do a cause and effect diagram. You do a cause and effect diagram. So these are the low scores, is the effect, and these are the causes. Now, not everything is responsible for low scores, so we have to do a Pareto analysis. So we studied some of the low scores and assigned the causes. Someone like industry interaction was not there, study hours were less, branch, I'm from chemical engineering. In chemical engineering, we scored low marks, as compared to, let's say, IT. Yeah, so people have various reasons, and we have collected all the reasons, and it is attribute data. Attribute data, we can do a Pareto analysis. So I do a Pareto analysis. And I get my Pareto. Pareto tells me that 23% of the time, the cause was found to be industry interaction. Not enough. Because those who had industry, like this is the preliminary analysis. Preliminary analysis telling me that this might be the reason, but I need to further investigate after some time. So here, industry interaction, study hours, branch versus blame. The branch like stream, a particular stream. Everyone scores low marks, so I can't help it. The root cause is the stream itself. Okay, and maybe classrooms. Attendance, so many other things, which are, of course, not much. They're not so significant. But let us take these one by one. Industry interaction. So I collected now samples. How much industry interaction, like how many days of training you had as an intern, or you had some exposure. So we collected the data, 20 days. One person, Mr. A, okay, 20 days. Ms. B, 27 days. And study hours, how much was the study hours? We collected the data. And then which branch you belong to? You're from MBA, okay, and management, chemical engineering, mechanical engineering, okay. Interest, one of the reasons was interest. The student is not interested, yeah. You should be interested. So you can see that you can grade the student based on the interest and how much interest he or she has got towards the subject. So interest was medium, low. So we checked one by one student, Mr. A, B, C, or whatever, and we collected for 15 students. Now, depending on the cause, the data, like continuous data, and if I want to know continuous and continuous, is course dependent on industry interaction. Now, both are continuous data. I can make a scatter plot. Scores and industry interaction. Oh, there is no relation. So don't worry about industry. It is nothing to do with the scores. Don't think you spend more time in the industry and you'll score high marks. Sorry. How about study hours? Is it related? Let us see. Again, I will do a scatter plot. And yes, positive relation. I can even get a set point. I can decide how much scores I want, and I can put my study hours, because that's what the data suggests from this college. Every university may have different analysis. Some universities doesn't depend on study hours, something else it might depend. So we're talking about the specific industry. You can even do a regression analysis, which gives you a straight line equation of its course versus study hours. I won't be able to discuss this more, but in the regression, if the p-value is less than 0.05, it's significant. Yes, okay. And I can say yes. Scores is equal to 2 plus 0.19254 times study hours. So you can decide a set point. Now all your, like in the regression equations are existing in your distillation columns and your refineries, reflux ratios, all the X factors which are affecting your factors like productivity, yield of my petrochemical products, the purity of my oil, okay, or impurities present oils is dependent on so many factors. So you have multiple regression. You can have as many factors. You can add 2, 3, 4, 5 factors. We call it as multiple regression. So this is what is done in the industry. Your processes, all the industrial processes, they have got their own regression equations. So decipher those, find out these, discover these regression equations. Why not? By just collecting small samples or a little bit of sample will reveal those equations. If they are related, of course. If they are not related, then leave it. Like, for example, industry interaction was not related. So I have got study hours as one of the root causes. Let us see scores and interest. Is it related? I will do a box plot. Why? Because one is attribute and one is continuous. The branch is continuous. Well, not related. Oh, sorry, interest I wanted. Interest, let me first show you the interest. So high, medium, low, I've got interest. Okay, so here I see that student with high interest scores high marks, and low interest scores lower marks. So that means I need to ensure, I need to do something about generating the interest in the students about the subject, or whatever you can do further root cause analysis, which interest we are talking about. So interest is a critical factor, but branch is not, which we saw just now. If you see branch, it is not affected. So I'm getting my root causes, and it's so easy to collect the data in any industry. I just took an example of a university just to correlate with the students, because you cannot correlate with this example maybe. But if you go to any industry, let me show you one example from the industry, maybe oil company. So this is the rig move time in the oil industry. So yeah, so this is the project, one of the largest oil companies in Middle East, and problem was high rig move time, low productivity, increased costs. So they wanted to do a project, and those who don't know what is rig move, for them, when the oil well is drilled at one particular time, or point of time, at one place, then once the drilling is over, you would like to transfer the whole structure, from one place to another place. That is known as rig move. So it was taking more than 5 days, 6 days. And of course, it would result in losses, because if you can drill more oil wells, why not? You can produce more oil. So it is taking around 5 to 7 days, and we would like to reduce it to less than 3 days. So that was the problem and goal statements. So the project team comprised of senior managements, engineers, and operators. Since the time I had become a Lean and Six Sigma black belt and master black belt, I've been into IT industry, banking industry, consulting industry, insurance industry, and of course, oil industry too, and chemical and petrochemical industries too. So after a long time, I got to wear my uniform for chemical engineer. I clicked a photograph, and we did a workshop in the oil fields. Yeah. Lots of nationalities, Emiratis, Saudis, Omanis, Indians, Americans, Venezuelans, British, all, different continents represented, language barriers, cultural barriers, but everyone understood the language of Six Sigma. Of course, which was doing a SIPOC. In the defined phase, do a SIPOC. So you have customers, drilling division, outputs, process, inputs, and suppliers. Then comes the project charter. So it is taking more than 5 to 7 days, and you would like to reduce it to less than 3 days. And if you are able to do that, it's estimated that we'll have 174 days of additional opportunity of oil production. So now we have got project time milestone as well. Project Gantt chart, where we can see that original plan, we are almost with the original plan. In measure phase, we took a lot of time because we earlier thought was we had all the data, but we realized that not all the data is available. So it took a little bit of more time, but more or less we completed the overall project on time. So data collection, we collected the data from various sources and process sigma level calculations. We found that we are at 0.81 sigma level. Process performance for the last 10 years, we have never been able to achieve the 4 days historically. Would it be possible to do it now? Let us see. And in the analyze phase, you can do different, doors. We call it process door or data door. Process door, you do the as-is process map, Gemba walk, value added, non-value added analysis. We call the waste as muda. Muda in Japanese means waste. The data door, cause and effect diagram, control impact matrix, box plots, scatter plots, multiple regression, ANOVA, design of experiments, all these tools were used. A Pareto chart indicated which are the rigs which were having biggest issues. We focused on that for Gemba walk. We did a Gemba walk, we did a Muda analysis, we implemented 5S, and we made a control impact, cause and effect diagram, box plots, scatter plots. Like sometimes we thought that distance, was responsible for the time taken to, the distance was responsible for the rig move time. Means if the two rigs were very, very far away, it would take more time, to move. But, scatter plot indicated that distance has nothing to do with the time. That means the root cause lies somewhere else. So all these analysis, we did a multiple regression. We created an equation of rig move time using the different factors. And we also did a design of experiments, which is again an advanced Six Sigma tool. So finally, we got the root causes, wasteful steps, start and pre-move, readiness, motivation, using tools like FMEA, chi-square, multiple regression, ANOVA, Gemba, and then we generated a lot of solutions. 635 is my favorite, so wherever I do the brainstorming sessions, we use 635, but you have got a lot of tools. We learn many tools in Six Sigma. You can use any one of them. So you have got, I'm not going to discuss the ideas here. So they implemented those ideas, and after that, they were able to, change the control limits, the time was reduced to 2.5 average. So first time in the last 10 years, they were able to reduce the rig move average time to less than 4 days. So they were able to sustain that for around 6 more months. And that is what, this is what is a typical Six Sigma project in the oil industry. We had some money as well generated, notional money. So additional 258 days of oil production, if I calculate the days saved, number of days saved every time. So 3 days on an average saved. Out of that, 86 rig moves per year translates to 258 days of oil production. So this is how, you do a project. So I just wanted to show you some projects. Now, I can, I think, open the floor for the questions. Yeah. If you have any questions, I'll be happy to answer. Okay, so now I see, some questions are already there. Since it's having, okay, yeah, okay, it's a comment, fine. So yes, I agree with you. So ability to make proper analysis is on the set of, so you should be able to collect the data. First, you have to believe that everything can be measured. That is one thing. Second is each and everything can be improved. Yeah, there is always a scope for improvement. That is what you should believe in. And once you have an opportunity, just collect small samples, 30, 40, 50, yeah, and 100, maybe 200, and make conclusions about the process and give suggestions. Okay. One question is, how related is the Lean Six Sigma with project management? Yes, so some of the project management tools are very much used in Six Sigma projects. So Lean Six Sigma is a methodology, yeah, which has a lot of tools and techniques. And you, apply these tools and techniques as you do the improvement project. So while you're doing the improvement project, you can apply the project management tools and techniques also. So they are closely related. And as I was telling that I conduct programs for PMP certification also, and I conduct programs for Lean Six Sigma Black Belt or Master Black Belts also. So some of the tools are overlapping, of course, but when I talk about the PMP, project management, we are talking about a large project, So lots of things like risk analysis on a larger scale, procurement management for a large project, plus human resources management, scope management, schedule management. So all these techniques are, taken. I would be happy to talk about project management in some of my future sessions. Why not? So that is about larger projects. And Lean Six Sigma, we are more focused on the small quality improvement project which we have chosen to improve a process. So tools and techniques, they are many times related, but of course they have got their uniqueness as well. So there are a lot of differences as well. So if you have any questions, I am open to questions. So how much success of Lean Six Sigma is related to leadership or manager? So it is actually, I would say, the most important factor of overall Lean Six Sigma success in an organization, and also overall success of a project, both. Either if I'm talking about like an organization is running multiple projects and whether it will succeed or not, that also. And even if you're talking about one project, in both the cases, leadership is the most important factor contributing to success, not the knowledge of course, knowledge contributes a lot. The enthusiasm of the green belt and black belt contributes a lot, but the most important factor is the senior management support. So if the senior management is not supporting, nothing works. So that's what we do when we are implementing Lean and Six Sigma. First thing is we get the senior management support by training them as champions. That is one thing. And when you are doing a project, individual project, there is a stakeholder analysis, which we learn in our green belt and black belt session. Then in that case, you identify all the stakeholders of your project, including the senior management, and keep the senior management informed about the progress of the project. And if you are managing them, engaging them effectively, you will definitely succeed. So to answer your question, yes, this is the most important factor of success. Okay. Then next question is, oh, which principles of Lean Six Sigma do you apply to your daily life and how has it? Oh, so I don't know if you noticed, some of my videos, my weight was too much. Yeah. So now I reduced it by 10 kgs by using a tool called FMEA, Failure Modes and Effects Analysis. I make control charts of my weight for the last 25 years. All the control charts, I process under control. If the control limits are too high, I would like to breach the control limits. I would like to process to go out of control, you know. And I take up small improvement projects, apply cause and effects, Pareto analysis, get my root causes. So that is one thing. Also, whenever we want to increase this, we have done to the organization. I told that I've written a book and I mentioned some of the tools and techniques. We want to, when we want to improve our revenues, and we want to breach our control limits, you know, slowly, steadily. Every company would like to do that, and every individual, if you are an individual, you would like to increase your salaries, isn't it? Earnings. So we have used those tools and techniques, and we have used to improve the relationships. So there also, I have written an article also in a newspaper on that, about how to improve the relationships using Lean Six Sigma tools and techniques. So yeah, these are some of the principles. FMEA, I maybe if time permits, I could have shown you, but I've got another video. I've put it in Anexas YouTube channel. If you subscribe to that YouTube channel, you will see a lot of my videos. This video also will be available on Anexas channel. So feel free to watch this video one more time. And one of the videos I have separately talked about FMEA, Failure Modes and Effects Analysis. You can have a look at it. In fact, this video will take some time. If it needs some editing, maybe it will take 2-3 days to post. Otherwise, I will send you one link immediately once I receive your phone numbers or email IDs. Once we get it, we'll send you a link. You know, you can have a look at one of the previous programs, which is similar in nature. Have you had a case where the control phase after learning Lean Six Sigma is re-evaluated? Yes. So sometimes if you're talking about the whole process is re-evaluated, in most of the cases, yes, it is. Or if you're talking about the whole, like when I did a project and suddenly I find that, you know, whole process is totally, you know, needs to be changed. So many times it has happened. So in both the cases, of course, we had some cases. One was Siemens. Siemens is, I'm sure many of you might be knowing. So we were doing some projects. So we totally redesigned the whole process. So that is one thing which we did. We have got, when you join our green belt and black belt sessions, we give you around 30 projects from 30 projects each in manufacturing, services, healthcare, IT, shipping, you know, so many projects we give. So one of the projects I remember is about it. So the data analysis software which you would recommend, I will recommend Minitab. It's 30 days trial is available. Again, if you are a green belt, we give you this software as part of the session. And so Minitab is one thing. And other thing is, if you want a little bit of AI, the Python is there. You can use that as well, but it's not required. Minitab, it takes us 2 hours to learn. So why to, if your intention is just to do data analysis, Minitab is good. Okay, so one question is it possible to predict how much time will it improve if it is, you're talking related to, you're reducing the time, processing time in a process. Is it possible to predict? See, Lean Six Sigma cannot predict how much you can reduce. That needs to be decided by the customer. That needs to be decided by the stakeholder, the manager or process owner. Lean Six Sigma can definitely tell you that which will be statistically significant improvement. So it will tell you the minimum improvement which it should be, you should achieve in order to claim that you have done some improvement. So it will tell you the minimum improvement. Like your let's say your minimum scores for 60 right now. Like average scores for 60, and if you say I increased it to 64. I would say it is not statistically significant. There is a tool called 2T test which you can use. But if it increases to 68 or 70, based on, again, 2T test, if I find p-values low, then this is, yeah, your improvement is significant. So Lean Six Sigma can give you the limits, like beyond which you can claim that some significant improvement has happened. So that is what Lean Six Sigma can do. But how much time it is possible to reduce the time to any extent. Of course, we are talking about achievable extent, and this has to be decided by the customer. Trial and error is common in the process. Sometimes it's not very common. It's mostly data-oriented, tool-based. So trial and error is a little bit used in the improve phase. We have a tool called design of experiment, where we design a case. Even the trial and error is very carefully designed. So we identify the factors, we identify the levels, and with these levels we experiment. And we find if there is an interaction between those levels. And if there is interaction, it's a good news, and we can discover, we can invent a lot of things. That's what all the automobile industries do. All the refineries, oil industries, how do they improve their productivity? By doing experimentations. All the research units, R&D, pharmaceutical industries, they're all involved in this. So they are using, but trial and error, even if you are doing, it is still systematic in Lean Six Sigma. And one of the examples is a design of experiments. Processes are made by people. That means that you have to change human culture or workforce culture after Lean Six Sigma. Yes. How do you handle? Okay, so we have a change management module in our green belt and black belt session. So one quickly, if I were to answer this, stakeholder analysis, we identify all the important stakeholders and we manage them. That is one thing which we do. And then one more thing is there are 3 types of resistances. Like suppose someone is resisting. So there are 3 types of resistances: technical, political, and cultural. So technical resistance, if we identify that person is resisting technically, we will invite him for training. We'll convince him using examples, case studies. If the person is resisting politically means he feels that your success will affect his power in the company. So then in that case, you have to address the what's in it for him. WIIFM, what's in it for me. So that so you have to address what's in it for that person. And once he gets convinced that, this, whatever you are doing is like for his own good, then of course, he or she would support. So that is one thing. Culturally means you have to change the culture of the whole group. So for that, you have to create first the 3 steps, create dissatisfaction with the status quo. Oh, we are not good. Look at them, look at the competitor. We are nowhere. Then second is create vision. Let us be number 1. Let us be top 5. Let's make it happen. Together we'll win. So that is vision. And then of course, the first step, that you have to tell what exactly needs to be done in small step-by-step approach. So even DMAC methodology really works well because it tells you step by step, like do a SIPOC, do a charter, make a histogram, get a sigma level, process mapping, move the identification, cause and effect, Pareto, box plot, scatter plot, regression, ANOVA, and some sequences there, and you just end up improving any process, just if you follow those steps, FMEA, failure modes, effects analysis, all these things. So if you keep on doing this, it's very, most cases you end up succeeding in improving anything. So this is very important actually, this is a very good question. Unfortunately, in Yellow Belt, we don't have so much time, so I can't, talk about the change management. But we have got, we take good examples and we discuss the change management, like how to ensure that we are able to, influence the stakeholders so that we succeed. Because if we engage the stakeholders perfectly well, together with correct usage of tools, both are important, your success is ensured. So that's a good question. Yes, Jimenez, yeah. Yeah, SPSS also can do what Minitab can do, yes. Okay, Renzo is congratulating me for the presentation. Information is easy to understand and very a good way of presenting the content. Very good. Thanks a lot. That helps. And please, write on LinkedIn about our program, and even on our page, you can connect. You can tag me or tag our this thing. This is required nowadays. In pandemic, all our you will say business has got affected. We used to consult a lot of companies, a lot of oil companies. Because of the situation, we can't go there, and much of the we can't do remote improvement in most of the oil industries. So obviously, we have found out other ways of sustaining. Ken Ellis, and we also conduct a green belt for students. We conduct at a very, very low cost to just $150. The green belt training is very. So if you are interested, you can contact us separately, and we'll be happy to conduct a session. You can enroll for one. Artificial lift projects like selection of a pump. Yes. We have got a lot of projects related to pump repair time, pump net positive suction head, NPSH improvement. No, we have done it. We have done it. That. So, yeah, so Alejandra is telling thanks. Alejandra Lopez is telling thanks. Okay, thanks a lot for listening to me. Good. So Elizabeth is telling congratulations. Okay, thanks for the excellent talk. Thanks to you too. How would a green, black, and superior black belt, superior means the master black belt, impact the competitiveness of a young professional in the industry? So, first of all, as an engineer, as a chemical engineer, petrochemical engineer, definitely you are equipped with some good knowledge to make to run an operations of a company. So that is definitely there. But not only you have to manage the operations, not only you have to run the process, you have to continuously think of improving the process. So the Lean Six Sigma, Green Belt and Black Belt tools, and even the Master Black Belt tools will help you to continuously improve the process. Or at least if you don't want to improve, it will be able to solve the problems, because you'll find a lot of day-to-day operations once you join the industry. No day is like a lazy day. every time some problem occurs and you are running firefighting. So it will help you in firefighting also, but more importantly, Lean Six Sigma tools and technique help you to prevent the fires or problems. So that is very, very important. Thank you, Dhruvil. Yes, thanks a lot. And thank you, ML Nunes. Okay, thanks a lot. And thank you, Carlos. So yeah, thank you, Daniel Zubia. Okay. So if we don't have any questions, so we can wind up the session. Yeah, so thanks for attending the session, and I am available. My name is Amitabh Saxena. I'm writing it for you. You can connect me on LinkedIn, and also you can like our Facebook page, Anexas Europe page, and you can attend a lot of webinars. I keep doing a lot of webinars, and a YouTube channel also, so why not? Okay, so thanks a lot, and we'll see you soon at any point of time. If there are something related to project management, I'll be happy to give a talk too. Thanks a lot.